In my last video, we talked about multiplying fractions. Today, we're going to be dividing fractions. Now, when you divide fractions, you actually have to multiply by its reciprocal. I'm going to show you what that means. The first question we're going to look at is over here. Example 2a, which is 2 over 5 divided by 4 over 9. Okay? In our first example, we have 2 over 5 divided by 4 over 9. Now, you want to pay attention to the divide by 4 over 9. We actually want to multiply by its reciprocal. What does it mean to multiply by its reciprocal? Well, the first word is multiply. So we're going to change this division sign into a multiplication sign. And then we're going to take the reciprocal of 4 over 9. So basically, all you do is you flip the numbers. So the numerator becomes the denominator, and the denominator becomes the numerator. At this point, all you need to do is multiply these fractions like I taught you in the previous video. So let's see if we can cross-reduce to make life easier for ourselves. So what we're going to do is we're going to find the greatest common factor of numbers that are across one another. So we're going to first take a look at 2 and 4. So the factors of 2 are 1 and 2, making it a prime number. 4 has the factors of 1, 2, and 4. As you can see, the greatest common factor is actually 2. So what are we going to do with this number 2? We're actually going to divide 2 by 2, and we're going to divide 4 by 2. Next, we're actually going to find the greatest common factor of 5 and 9. Those are the other numbers that are across from one another. The factors of 5 are 5 and 1, whereas the factors of 9 are 1 and 9. And as you can see, the greatest common factor here between 5 and 9 is 1. Now, what are we going to do with that 1? We're going to go all the way back up here, and we're actually going to divide 5 by 1 and 9 by 1. And this step is redundant as anything divided by 1 remains the same, but I'm just going to write my work in anyways. So 2 divided by 2 is 1, 5 divided by 1 is 5, 9 divided by 1 is 9, and 4 divided by 2 is 2. Now, at this point, you can go ahead and just multiply the numerator, so 1 times 9, and you can just go ahead and multiply the denominators, 5 times 2. So 1 times 9, let me just make some space. 1 times 9 is 9, and 5 times 2 is 10. And that is our final answer. I cannot reduce 9 over 10. As 9 is a prime number, so its factors are 1 and 9. Both numbers are divisible by 1, but 10 is not divisible by 9, so that is it. In our next example, we're going to look at 3 and 1 over 2 divided by 6 over 7. First off, you should notice that 3 and 1 over 2 is a mixed number. As we've done in previous lessons, you want to convert this mixed number into an improper fraction before we do anything else. It will make life a lot easier. So what we're going to do is we're going to take 3, multiply it by 2, and then add 1. The denominator stays the same, as well as the divide by 6 over 7. We're not going to touch it yet. So over here, you want to use your bed mass. 3 times 2 is 6. Everything else stays the same. Again, I'm just showing you all the steps. And 6 plus 1 is 7. Everything else stays the same. So what we just did there was changing a mixed number into an improper fraction. And let's just make some space for ourselves. What you'll notice is that we have a divide by 6 over 7. As in the previous question, we actually want to multiply by its reciprocal. So the 7 over 2 stays exactly the same. We're first going to change the division sign into a multiplication sign, and then we're going to find the reciprocal of 6 over 7, which is just 7 over 6. At this point, you can go ahead and treat this just like a multiplication question. So we're going to multiply the numerators, 7 times 7, and the denominators would be 2 times 6. Let's go ahead and simplify that. 7 times 7 is 49, and then 2 times 6 happens to be 12. Don't forget that we usually want to express our final answer in its lowest terms. So 49 over 12 actually is an improper fraction because the numerator is greater than the denominator. We want to convert this into a mixed number, so a number that contains an integer and a fraction. Let's just make some space. What you're going to do is you're going to take 49 and you're going to divide it by 12. Now 12 goes into 49 4 times. So 4 times 12 happens to be 48. You're going to go ahead and find the difference, which is 1. And that means we have a remainder of 1. What exactly are we going to do with these numbers? Well, the 4 actually becomes the integer. The remainder of 1 actually becomes the numerator, and the 12 actually becomes the denominator. And there we have our final answer of 4 and 1 over 12. You cannot reduce 1 over 12, so we can just leave it. In our last question, we're going to look at 1 and 2 over 9 divided by 7 and 1 over 3. Right off the bat, you'll notice that both of these are mixed numbers, meaning they contain both an integer and a fraction. That's not very useful to us, so we are going to change these mixed numbers into improper fractions. So let's go ahead and do that. So here we have 1 times 9 plus 2 over 9. Division sign stays the same. 7 times 3 plus 1 divided by 3. I'm going to skip a few steps here. 1 times 9 is 9, plus 2 is 11. The denominator stays the same. 7 times 3 is 21, and 21 plus 1 is 22, and the denominator stays the same. At this point, you actually want to multiply by its reciprocal. So multiply by its reciprocal. So let's make some room for ourselves. So the 11 over 9 stays exactly the same. We're going to change the division sign into a multiplication sign, and then we're going to write the reciprocal of 22 over 3, which is 3 over 22. At this point, we want to see if we can cross-reduce. Remember, cross-reducing makes life a lot easier for us. Remember, we want to find the greatest common factor of the numbers which are across from one another. So that would be 11 and 22 and 3 and 9. So let's first look at 11 and 22. So the factors of 11 are 1 and 11, making it a prime number, whereas the factors of 22 happen to be 1, 2, 11, and 22. You'll notice that the greatest common factor happens to be 11. What are we going to do with this 11? We're actually going to divide 11 by 11, and we're going to divide 22 by 11. Now we're going to take a look at the other set of numbers that are across from one another. We're going to take a look at 3 and 9. So let's write out the factors for 3, which happens to be 1 and 3, making it a prime number. The factors of 9 happen to be 1, 3, and 9. Immediately you can see that there is a common factor, and it happens to be the greatest common factor, and that is 3. What are we going to do with that number? Well, we're going to take 3, we're going to divide it by 3, and we're also going to divide 9 by 3. Let's go ahead and simplify that. So 11 divided by 11 is 1. 9 divided by 3 is 3. 3 divided by 3 is 1, and 22 divided by 11 happens to be 2. At this point, you can go ahead and just multiply the numerators and denominators. So 1 times 1 over 3 times 2. 1 times 1 is 1, and 3 times 2 is 6. And 1 over 6 is our final answer. We cannot reduce 1 over 6 since the factors of 1 are just 1, and anything divided by 1 remains the same. So 1 over 6 is our final answer.